For the warm-up, let's find the zeros of x squared plus 4x plus 5. So we could do this by factoring, by graphing, or by using quadratic formula. So let's use quadratic formula to review. First step, let's find a, b, and c. A is the number next to the x squared, which is 1. B is the number next to the x, which is 4. And c is the number by itself, which is 5. So if we plug in a quadratic formula, the first step looks like this. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. The second step is I want you to figure out these three numbers, the first number, the discriminant, the thing under the square root sign, and the number on the bottom. So here's what it looks like. We have x equals -4 plus or minus the square root. You should be able to type this in right here. So let's do 4 squared minus 4 times a, which is 1, times c, which is 5, and we get -4 all over 2. And then yesterday we talked about if you have a negative discriminant, we can't find the square root of -4 here. There's no number times itself that's -4. So we stopped and we said there's no real solution. And if we graph that, it should not touch our x-axis. So let's type this graph in. So we have x squared, let's go here, plus 4x plus 5. And we can see that there's no real roots, there's no real solution. It doesn't touch your x-axis. It says, here's the graph. How many real solutions are there? There's 0 real solutions. All right, so first of all, before we get into complex numbers today, which is a way to still solve without finding the real solutions, let's review quadratic formula. It's x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And the discriminant is that thing under the square root sign, b squared minus 4ac. And remember, in order to use quadratic formula, it has to be in this form, ax squared plus bx plus c equals 0. And remember, if the discriminant is positive, that tells you there's 2 real solutions. I'll put roots or zeros, and it means it crosses your x-axis twice. If your discriminant is 0, there's 1 real solution. And it would cross your x-axis once somewhere. And then like the warm-up, if the discriminant is negative, then there's 0 real solutions. I'll put zeros. And your graph could look something like this, where it doesn't touch the x-axis at all. In order to solve quadratic equations like the warm-up, when there's a negative number under the square root, mathematicians decided to expand the number system. So we'll watch a video in class, and you can go here if you want to see it too. It talks about imaginary numbers. And so the imaginary number is the square root of -1. We'll represent that as I. And then if we have I squared, that means the square root of -1 times the square root of -1, which equals -1. So these are the 2 numbers that we have to know right here, and I'm going to show you how to use them. So the first thing is simplify the square root of -9. We can break this apart into the square root of 9 times the square root of -1. We know that the square root of 9 is 3, and we know that the square root of -1 is I. So another way to write the square root of -9 is 3i. Let's try the next one, the square root of 50. So square root of 50, square root of -1. And then remember, when we simplified radicals, this is the same as the square root of 25 times the square root of 2 times I. And then if I keep going, that's 5. I'm going to put the I right next to it, and then square root of 2. So here's another way to write this, where we pull out the biggest square number and we pull out the negative. The next one here, I'm going to do my work here. The 2 plus, we don't change. But the square root of 12, again, I'm going to break it up. This is the square root of 4 times the square root of 3 times the square root of negative 1. The square root of 4 is 2. The square root of negative 1 is I. And then we have the square root of 3. So this is 2 plus 2I times the square root of 3. So I'm going to practice pulling out that I. Let's try the next one. We have our negative 3 we don't touch, plus the square root of 10. I can't simplify any further. There's no square number I can pull out besides 1. So we have the square root of I, or square root of 10 times I. The next one is 7 minus, I'm going to break this apart, the square root of 100 square root of 2, square root of negative 1. And we'll rewrite that 7 minus, this is 10, here's the I, and then square root of 2. A complex number where A and B are real numbers. A is the real part and BI is the imaginary part. You can see how we wrote all these. The real part comes first and the imaginary part comes second. Okay, so how do we deal with these imaginary numbers? Well, when you add and subtract, it's just combining like terms. So first I'm going to add the real numbers. 4 plus 10 is 14. Negative 7 plus 6 is negative I. Let's take a look at this, and we do have to distribute the negative. We have 7 minus 12 plus 8I. Combine your like terms. 7 minus 12 is negative 5. Keep your imaginary part second. Here's the answer. This one right here will distribute. 4 times 13 is 52, plus 12I, plus 6I. Combine like terms. We get 52 plus 18I. So treat your I just like a variable, like x, and combine like terms. When multiplying complex numbers, remember I squared is negative 1. So let's take a look at the first example. We got 60 minus 30I, and then there's our answer. This one right here, we have to use a box, or FOIL. We have 2 minus 3I. We have 4 plus 7I. 4 times 2 is 8. 4 times negative 3 is negative 12I. 2 times 7i is 14i. And negative 3i times 7i is negative 21i squared. So the only difference is here's I squared is negative 1. Negative 21 times negative 1 is 21. So now let's combine like terms. Put our real numbers first. 8 and 21 is 29. 14i minus 12i is 2i. Excuse me. So there's our answer, 29 plus 2i. The last example, we have 2 minus 3i. So we're going to multiply 2 minus 3i, 2 minus 3i. We have 4 minus 6i. 2 times negative 3 is negative 6i. And then we have 9i squared. Again, I squared is negative 1. 9 times negative 1 is negative 9. Combine like terms, we have 4 minus 9, which is negative 5. And then negative 6 minus 6 is negative 12i.